Hi kids, we will be going with this paper discussion. You can look at the first question. The height of the sea level under the influence of tide in a city of Mumbai during a full moon can be modeled as A sin omega t, where A is the amplitude, omega is the frequency, such that the tide occurs every 12 hours. The sailors of the ship would like to know whether they will be able to dock when they arrive at the port. The problem is that their ship can anchor the quay only when the water level has fallen not more than A by 3 below the maximum level, and the sailors do not know at what time the high tide occurs. What is the probability that they arrive at a time when they can anchor the quay? Now, if it is performing SHM, this is the maximum, and from here it shouldn't be below A by 3 from here, so it should be somewhere here. Now, you know, as it is performing SHM, you can see it as circular motions projection along y axis. So, in circular motion, if it is in this region, then its y axis projection will be in this region. Now, if I want to calculate this angle, this length is A by 3, so this is 2A by 3, so this angle I can calculate. So, this angle and this angle. So, during this much angle, it is in convenient situation, the rest is not convenient. So, and omega is constant, so you can go with probability is same as the angle available, because the time omega is same everywhere, right. So, the needed angle is 2 times of theta and overall angle available is 2 pi. So, the probability where we can find it in this scenario is this probability. If you want to convert, you can convert into sin inverse, the same thing, you will be getting the needed answer. A person standing upright looks into vertical plane mirror hanging on the wall. The height of the person's eyes above the floor is 180 centimeter. The height of the mirror is 160 centimeter. Mirror is hung at a distance 30 centimeter from the floor. 30 centimeter from the floor. At what distance from the mirror should the person stand in order to see themselves at full height? Now, so yeah, this is, assume this is man, and there is mirror here. Assume it is large mirror for a better understanding what is going to happen. So, image will be formed here at the same distance. So, you can see the rays coming from here will be hitting and will be reaching the man's eye, or I can directly draw the rays from here to here. I mean, this image will be looking like this only. So, if a man is seeing his legs, he will be feeling like they are coming from here. So, I should be able to draw a line from here to here. So, and similarly, if you want to see the head, these rays. Now, I mean, if the eyes are at the top. So, basically, if you notice, if this part of the mirror is there, that is sufficient enough for him to see his full image. And in fact, you can clearly see that will be, these two will be similar triangles. So, this will be half of this length, half of this length. So, in the given question, they were already saying this was only 30 centimeters. So, it was sufficient enough. It was sufficient enough. He can see his full image. Now, in the same way, if the mirror was shifted, I have drawn the shifted figure. Now, image will be shifted. Now, notice these two are two different figures. Mirror is here, mirror is far away. Again, if a man has to see his full image, this part of the mirror is only needed, again, which is half of this length. So, mirror length is going to remain, the minimum mirror length needed is half of the man's length, and it should be placed at this location. So, in the given question, there is extra length here also, extra length here also, so that doesn't really matter where you are going to place, man will be able to see the full image. As a result of collisions and counter propagating beams containing lead. Okay, so yeah, so there was a scenario and they were asking what is the cost of energy to produce 1 gram of gold, and in the question they have given mass of the elements of this thing. They have given mass of elements, but we need only mass of nucleus. But so you should be subtracting number of electrons from this. So number of electrons is 79. So you need to subtract 79 mass of 79 electrons, mass of 79 electrons, mass of 2 times of 79 electrons. So anyway, they will be getting cancelled. So we just go with elements difference mass. Difference in elements mass. Generally, we have to calculate only nucleus mass difference, but it turns out to be elements mass difference also turns out to be the same. So final mass will have some energy, initial mass will have some energy, mass is going to be equivalent to energy, right. So, final mass energy minus initial mass energy will be giving us what is the energy we supplied. Now we need for only one nucleus formation, so we will be seeing what will be the half of that. So if I take half of this scenario, then it is going to be one nucleus and 3 protons, or else you can take 2 nucleus, 6 protons, 16 neutrons and 2 times of this, and whatever answer you will be getting you divide by 2. So that is going to be 77.035 delta mc square. So that is the energy we supplied to make one nucleus. But how many such nucleus will be there in 1 gram of gold? This will be the number of moles into Avogadro number. These many nucleus will be there. In order to make each nucleus, we supplied this much energy. So to make this many nuclei, we will be supplying this much energy, which is 3.77 into 10 power 10 joules. Now kilowatt hour in joules is going to be this much. So when you divide this with kilowatt hour, you will be getting number of kilowatt hours energy we supplied. So then we need to multiply with 1.5, which is the cost factor, right? Then you will be getting the required answer, which is option C. A load of mass m is suspended from a system of identical massless rods connected by hinges as shown in the figure. Determine the force that stretches the nth upper horizontal rod. You can go with the given solution available, or they were talking about, see, it is massless rod, the force will be only along the rod, whether it is compressive or elongative. I just represent it randomly, I do not know whether it is tensile or compressive. Now if I look at this as my system, there will be force here, there will be force here, there will be force here, there is external force, all other forces are internal forces. So I want to calculate this, so I will be taking torque about this. As it is in equilibrium, net torque should be 0 about any point. If I take this, torque due to these two forces is already 0. So torque due to this force should be balanced by torque due to this force. Root 3L by 2 into this should be equals to this distance, which is going to be NL minus L by 2 into mg. Then you will be getting the required answer, or you can look into the given solution and you can go step by step. The cross section of a gate is as shown in the figure. The dimension normal to the plane of the paper is 8 meter and the shape is x equals to 0.2 y square. The gate is pivoted at O. Water depth is 2.5 meter. Neglect the atmospheric pressure. Then horizontal component of force acting on the gate due to water. Vertical component of force, torque of the force on the gate. So what I will be doing is, they were asking what is the force exerted by water on this. So instead of that, I will be calculating what is the force exerted by this on the water. So I will be drawing the free body diagram of the water. I will be drawing the free body diagram of the water. If I draw the free body diagram of the water, there is its own weight and there is force from this side. Both of these should be balanced by this curved surface. So vertical component of this curved surface force should be balancing the weight of the water, and horizontal component should be balancing this force. Now this force is easy to find, average pressure into area, rho, or pressure at the centroid into area, which is going to be 250 kilo. So the meaning is, this is going to exert a horizontal component of force 250 kilo. Now similarly, if I want to calculate weight, I should calculate what is the area and multiply with the length to get volume, then density into volume into g. So if I want to find an area, find the area, I will be taking element at a distance y, this value is going to be x and this is going to be dy. So area of that element is going to be x dy. If I integrate, I will be getting the total area. If I multiply the total area with the length inside, I will be getting volume. If I multiply the density on g, I will be getting the weight, right. So this weight will be balanced by the vertical component. Now I will be so now they were asking about the torque. So now I will be taking this water plus this thing as my system. So net torque about this point should be 0. So this force torque and weight's torque should be balanced by torque about this, or maybe I can say, as the water is in equilibrium, torque because of this force and weight will be balanced by torque because of these two components. So basically I want to calculate what is the torque because of this force and the weight. Now if I want to calculate torque because of this force, then I will be taking some element at a distance y. At a distance y, pressure is going to be rho g y, but from here the distance is going to be h minus h. This is h and this is y, h minus y. So pressure into area. This is dy. This thickness is dy and into the plane length is L. Pressure into area into distance from here. When you integrate, you will be getting what is the torque because of all these forces. Now similarly, if I want to calculate torque because of the weight, I will take some element, and if I take some element at a distance y, this length is x, so its weight is going to be, it depends on the volume. So this area is x into dy and into the plane length is L. So this is volume, rho into volume into g is weight, and weight will be acting at the center even for the torque. So perpendicular distance is x by 2. When you integrate, you will be getting what is the torque because of the weight. So we got torque because of this and torque because of the weight, which will be balanced by torque by the curved surface on the water. A horizontal conducting loop made of wire of resistance per unit length R in the shape of regular hexagon with side length A, placed in homogeneous magnetic field with magnetic induction vector B perpendicular to the plane of the loop. In the plane of the loop, a straight conductor L greater than 2A and resistance per unit length R moves parallel to side AF of the hexagon. If the motion is uniform and the velocity is V, then they were asking couple of options. So basically what you need to do is you should understand conductor is moving in a magnetic field. So if there is an EMF getting induced, that is motional EMF. So you can use V bar cross V bar dot TL bar. Then you will be getting EMF. From there you have to find current. If you find the current, then ILB is the force. Then current, once you know potential difference, you can find. Power loss also you can find. Just the calculation is very, when you have to write neatly. The scenario is going to look like this. When it has moved by distance x, this length is going to be 2x by root 3. So resistance is going to be this much. This length is here. Resistance is this much. Same thing. Now out of A, this is 2x by root 3, so this will be A minus 2x by root 3, so its resistance is this much, this much. Now this also has a resistance. Now you need to calculate this length. If this is x, this is going to be x by root 3, this is x, this is going to be x by root 3. So A plus 2x by root 3 is the length, so resistance is this much. Now V bar cross V bar dot DL, PLV. Now where is length is A plus 2x by root 3. Now this is the EMF. Now this set of resistors and this set of resistors, this entire thing is in series, this entire thing is in series. Now this set and this set will be parallel, which is in series with this. Then you need to calculate current. Rest all is current electricity question, but the only thing is you have to write big equations. Though you don't have to use much brain, but it's big equations. You try to do it by yourself, and in case if you want to do, then you can refer the given solution. Mostly I won't be updating the solution, it is going to consume time. In a YDSC, a parallel beam of light of wavelength 6000 angstrom is incident on slits at an angle 30 degrees. A and B are two thin transparent films, each of refractive index 1.5, thickness of A is 20.4. Light coming through A and B have intensities I and 4I respectively on the screen. Intensity at point O, which is symmetric to the slits, is 3I. Central maxima is somewhere above. And they were asking about maximum intensity, minimum intensity and fringe width. All this you can directly calculate, because I didn't do the calculation for C and D, but you should be able to expect. So intensity is given as I and 4I, so I can take amplitude as A and 2A. So maximum amplitude will be 3A, so maximum intensity will be 9I. Minimum amplitude will be A, and so minimum intensity is going to be I. So C and D will be correct. Now fringe width. Fringe width has nothing much to do with this and this, because for every point this length and this extra path length is going to be same. So for fringe width it is going to be the normal thing only, which will give you option B. Now they were telling central maxima is here. So this is traveling extra path of d sine 30. Now apart from that, okay, there is an extra path of mu minus 1 into t. For this guy, an extra path of mu minus 1 into t, and from here to here, extra geometrical path length of dy by d. This guy will be having extra here when we are going here. So this guy is having an extra of d sine theta mu minus 1 into t, but this guy will be having an extra of mu minus 1 into t and dy by d. This length will be more than this length. So that is going to be 0, they said. So, central maxima is somewhere here. So, the meaning is this particular expression should be positive quantity that you can understand normally also. So, path reference here should be positive quantity. When you take this as this minus this, it has to be positive quantity. Now, there they said intensity is 3 times. So, amplitude is root 3 times. So, resultant amplitude is a1 square plus a2 square plus 2a1 a2 cos theta root equals to root 3 times of a. When you square it, you will be getting cos theta is some particular value. So, for that the phase difference in the nearby 0 to 2 pi is going to be this much, path difference is going to be this much. Now, you can see it can happen repeatedly. So, lambda plus lambda by 3 or lambda minus lambda by 3, it is of some such form. So, I can say the path difference there has to be lambda plus or minus lambda by 3 form. Anyway, that does not really matter here, because they were asking whether 240 micro will fit here or not. You know this has to be positive, but if you substitute 240 here, it is going to be a negative quantity. So, it does not fit. It does not fit into the condition of central maxima is forming above. So, we are going to leave that option. The electrical circuit shown schematically in the figure consists of 3 capacitors C1, C2, C3, a coil of inductance L and source voltage U0. At the initial moment of time, the capacitors are not charged and the current in the coil is 0. The switch K is closed. Assume that the resistance of connecting wires is small. Maximum current through the coil, voltage across capacitor C2. So, that is kind of new for us. So, we will be taking help of math. I will be assuming current is here is I, current here is some other I. So, charge here is Q. So, by this assumption, the rate at which discharge increasing is I. Similarly, discharge is capital Q, the rate at which discharging is increasing is I. So, now this and this, those plates were isolated. So, summation of these 3 charges should be 0. So, this is going to be capital Q minus small q. Then I will be writing loop equation here and I will be writing loop equation here. Now, we need to solve for them. I will be borrowing them. Now, if you notice carefully, small q is coming only as q, its differentiation is not coming into picture. So, eliminate small q from these 2 equations. Then you will be getting equation in terms of q and q double dash. Then you can see it is going to be of the form SHM. I am just writing q double dash as q minus cu naught by 3 whole double dash, so that it looks like something double differentiation equals to minus omega square times of that thing. Then the general solution is that particular thing equals to a sin omega t plus b cos omega t, where this is omega square. Now, yeah, we have 2 unknowns, so we need 2 initial conditions. Let me differentiate this also. If I differentiate this, I will be getting this much. Now, I know at t equals to 0, q was 0 and q dash was also 0. At t equals to 0, q is 0 and q dash is also 0. When I substitute, I will be getting a value and b value. B value is this much, a value is 0. So, when I substitute it back, then I will be getting the q value. So, when I differentiate it, I will be getting the I value. Now, what is capital I? Capital I is the current in the inductor. Capital I is the current in the inductor. What is its maximum value? Its maximum value you can find when it is, this is going to be minus 1, right. Now, similarly, once you find q, capital Q, you can substitute it back to get small q. Then they were asking what is capital Q minus small q or small q minus capital Q, that you can do by yourself. In an experiment to determine the charge to mass ratio, so anyway, so you can see there is an error in this, there is an error in this, there is an error in this. If there is an error in these things, what will be the possible error in this? And the errors were small, so we can go with the differentiation. There were errors only in this, so yeah, so rest all things I am going to call it as constant. So, when I take logarithm on both sides, logarithm of that constant and logarithm of this stuff, then you will be differentiating, but you need maximum possible error in this. Maximum possible error in this will happen when this is positive, this is negative and this is positive. So, eventually you are going to write mod of this and mod of this, right. Then these values were given in the question. Then probably sometimes you need to do in percentage. I mean, I didn't write 0.1 and all because you should understand that is going to get cancelled. I just wrote it just for calculation. delta V by V is going to be 1 by 20, delta R by R is going to be 0.1 by 3.4, delta I by I is going to be 0.02 by 1.92. A reversible heat engine in a satellite operates between a hot reservoir and radiating panel. Radiation from the panel is proportional to its area and to T2 power 4. Determine the minimum area of the panel for an output of 1 kilowatt. If T1 is 1000, the panel behaves like a black body. So, in all these questions we will be drawing this figure. Heat is taken from this and some work is getting done, which was given in the question as 1000, and Q2 is going here, which is getting radiated as sigma A T2 power 4. Now, by energy conservation, this energy should be equal to this plus this, and as it is reversible process, change in entropy will be 0. So, Q1 by T1 equals to Q2 by T2. Then you will be utilizing both the information. You will be finding that thing was Q2. You want to write Q1 was not known, so you want to eliminate Q1. So, you find Q1 from here, substitute here, then you will be getting Q2 in terms of W. Now, Q2 was this thing. So, when you substitute it back, you can see the two unknowns are A and T2. So, if this has to be minima, this has to be maxima. This will become maximum when its first differentiation is 0. When you do that, you will be getting T2 is 750. So, when T2 is 750, this A will be minima. So, you will be plugging the value back. You will be plugging the value back here, so that you will be getting Q2 value. Q2 is sigma A T power 4. A certain designer built a complicated heat engine whose working substance is n moles of monatomic ideal gas operating in a cycle that forms a triangle ABC. Calculate the efficiency. Understand efficiency is work done by heat given to the gas or heat taken by the gas. Work done is easy to calculate, area under this graph. Notice this carefully, from here to here, work done by the gas is positive and temperature is also going to increase. Pressure is increasing, volume is increasing, so temperature will be increasing. So, change in internal energy is also positive. So, Q value is going to be positive for this entire thing. Work done is area under this graph. Change in internal energy is NCV delta T. Adding them is going to give you heat taken by the gas. Now, similarly for this process, any small process, work done is going to be negative and temperature is going to reduce. At constant pressure, volume is reducing, temperature will be reducing. So, yeah, anyway it is constant volume process, so constant pressure process. So, NCP delta T is negative, so Q value is negative, so we do not have to bother much. This thing, if you notice, when you are going along this, pressure is reducing, volume is increasing. So, you do not know what is happening to temperature. Work done may be positive, but you do not know what is happening to change in internal energy. So, you have to be careful on that. So, we will write the line equation so that we understand stuff. So, we write this line equation, and energy conservation for any process is going to be this much. Now, we want to see where is dq positive. So, for that, this is energy conservation, this is the line we are talking about. So, we will plug in this information back. du is NCV delta T, nr dt I can write as PdV plus Vdp by using gas law. Then instead of dp I am substituting it back so that I can see dq by dv. dq by dv I want to see when is it 0. When is it 0, or when I modify it, I will be getting dq by dv will be of this form, The meaning is, if this is less than this, then dq is going to be positive. If this is greater than this, then dq is going to be negative. If this is equals to this, dq is going to be 0, right. So, when you see here, till v is less than 2.5 V naught, dq is going to be positive. 2.5 V naught will be somewhere here. So, from here to here, dq is going to be positive. So, we need to calculate only that. Be careful, dq is only positive from here to here somewhere. So, you need to calculate only that. After understanding that, so you integrate this from 1.5 V naught to 2.5 V naught, because we understood dq is only positive till 2.5 V naught. Then that is going to be the positive q. The rest is going to be negative q, we do not really bother about. So, work done by positive q, which is 5, and here 2, 7. That is going to give you efficiency, right. Understand, whenever this kind of line comes, you be careful about that. A particle of mass m is embedded at a distance r by 4 from the center of massless circular disk, which can roll without slipping on inside surface of a fixed circular cylinder of radius 3r. The disk is released with 0 velocity from the position as shown and rolls because of gravity. All motion taking place in the same vertical plane if the reaction force acting on the disk at the point of contact when it is at the lowest position is alpha mg, then find value of alpha. So, I think this rolling constant question, it came in some of your exam previously, that rolling coin question. So, if I leave it, the center of mass of this thing is going to go this way, the line joining this and this center of mass, not center of mass or geometrical center, is going to rotate. Anyway, this total was 3r, this is r, this is r, so with radius 2r. So, this center, this geometrical center will be performing circular motion of radius 2r with angular velocity omega at any moment, let me say. Then angular velocity about the center is omega, let me say. Then as they said, it is pure rolling. Velocity of this point, you can see it as velocity of A and velocity with respect to A. Velocity of A is 2r into this omega, velocity with respect to A is this much. Understand, it has nothing to do with center of mass, we are talking about relative velocity. Relative velocity, velocity of some point, you can see it as velocity of A and velocity with respect to A. From there, when you integrate, you can see it is, while it is going from here to here, it is traveling, omega dt is going to be pi by 3. So, the meaning is about this, it is going to rotate by 120 degrees, 120 degrees. Now, understand, mass is here, if it rotates by 120 degrees, mass is here, if it rotates by 120 degrees, it is going to become vertical, it is going to become vertical, right. So, if this is 60, this is 60, this is 120, if it rotates 120 degrees, it is going to become vertical, it is going to become vertical now. Now, the forces are mg and normal. Then anyway, so first of all, we will be doing energy conservation. Okay, so when compared to this one, the mass is at a height 2r plus r by 4, 9r by 4, but we need only vertical component cos 60. So, this is the initial potential energy, initial kinetic energy. When it comes here, this is 2r minus r by 4, that is 7r by 4 potential energy plus kinetic energy, where v is the velocity of this mass, or you can see it as motion velocity of A and velocity with respect to A. Anyway, that I am talking about here, velocity of A. When it reaches here, let me say this omega is omega naught and this omega is omega naught. So, velocity of center, velocity of A is this much. Now, velocity about A, both are going to add up for this guy, right, which is 5 by 4. I mean, when we borrow that relation, substitute, you will be getting this much, which you should be expecting, because as it is pure rolling, you can say about this point everything is going to perform circular motion. This distance is 5r by 4, right, but we do not need all that. What we need is, what is the normal? So, you can see there is only one mass. So, net force should be equal to that mass times of acceleration. Now, from here you will be getting, by energy conservation you will be getting velocity. If you substitute this back, you will be getting omega also. All those things are manageable. Now, net force, understand, this is the only place probably you might be making mistakes sometimes. The net force is going to be N and mg, both are in the opposite direction. So, I am taking net force in this direction, N minus mg, that equals to mass times of acceleration of this mass. Now, acceleration of that mass is hard to find, because on that mass there are other forces, like on the disk and this mass system, the only forces are mg and n. So, you can see acceleration of A, and you can see this acceleration as acceleration of A and acceleration with respect to A. Acceleration of A is performing circular motion. So, acceleration of A is going to be omega square r in this direction. At least we are bothered about acceleration only in this direction, at least. So, acceleration of A in this direction and acceleration about A in this direction we need. Acceleration of A in this direction is omega square times of 2r, and acceleration about A in this direction is small omega square times of r by 4. Both are in the opposite direction, but we have taken net force in this direction. So, we will write acceleration in this direction. Acceleration of A in this direction, acceleration about A in this direction. Then we know all the values, it is just about substitution. Energy conservation, pure rolling constant, and looking at the acceleration as acceleration of some good thing which we know and acceleration about that good thing. See, here we are talking about velocity of A and velocity about A. Velocity of A and velocity with respect to A, acceleration of A and acceleration with respect to A, this is relative motion. But if you want to write kinetic energy and angular momentum, you can't write kinetic energy of A and kinetic energy with respect to A generally. You can do that only when you are talking about motion of center of mass and motion about center of mass. Similarly, angular momentum also you can't. You can write only angular momentum of center of mass and angular momentum about center of mass. You can't do it about any other point like angular momentum of A and about A. If you want to understand it better, you can look into the derivation, but relative velocity, relative acceleration you can do for any point. A glass trapezoidal vessel with a small angle 6 degrees is filled with water of refractive index. A parallel beam of light is incident on the vessel. Behind the vessel there is a converging lens of focal length. On a screen placed, a bright spot is observed. How much this point will move if the vessel is removed? So let us remove the vessel first. If you remove the vessel, where they will be focusing? They will be focusing at the focus in the focal plane. Now when you put this one, this is almost like a prism, so the rays are going to bend by an angle, some delta. So the ray which is passing through center of the lens is going to go this way, and we know the image will be forming on the focal plane. We know the ray is going to go by this way and image will be forming on the focal plane, so image will be forming here. So where this distance is going to be f into delta. The rays which are going to go this way, they will deviate by an angle delta, which is for small angle prism. Now if you extend this, you will be getting a prism of 2 alpha. So deviation is going to be this much. So once you know deviation, then so the ray passing through the center will be making an angle delta, so it will be forming an image at a distance f delta, right? And you need to, when you write alpha, obviously that is in radians. The equilibrium position of mass m occurs when y is 0 and yb is 0. When the attachment B is given a steady vertical motion, the mass m will acquire a vertical oscillation. Find the angular frequency omega for which the oscillations of m tend to be excessively large. The stiffness, okay. So generally, if we are not aware of anything, we will be writing f equals to ma. So if it has moved by distance yb and if it had moved by distance y, the length reduced in the spring is 2y, the length increased in the spring is yb. So net increment is yb minus 2y. So spring force is going to be k into this much, but if you write f equals to ma for this spring force, if this is t, this is going to be 2t. So on this one, force is going to be 2 times of spring force, that equals to mass times of acceleration. Now you can see it's a second order differential equation, yb value is substituted. So we need to solve it, or you can understand it is going to be some kind of resonance situation. So the frequency with which you need to vibrate should be equals to the natural frequency of the circuit. Natural frequency, or you can see from here itself natural frequency, or if you simply see if this is fixed and what is the natural frequency of the circuit, it is going to be 20. So with what frequency you will be vibrating, angular frequency, it should be about the natural angular frequency. And if you want to solve this mathematical expression, it is not very comfortable for us, but still I am attaching something related to that. You don't have to pay attention to this, just in case if someone is really worried about what is happening, maybe you, how you are solving math, you can look into this, or the physics version of the same thing is also attached here for a quick revision in case if you want. A uniform thin L-shaped rod of mass m carries charge q uniformly over its length. Rod is rotating about axis through end A as shown. If AB equals to BC equals to L, then magnetic dipole moment of rod is, and it is charge density and mass density ratio is constant, so you can go with gyromagnetic ratio. gyromagnetic ratio. For that you should know what is moment of inertia. Moment of inertia about this axis for this rod is m by 2 L square by 3. For this rod about center of mass is this much, then you will be using parallel axis theorem. So, net total moment of inertia is this much, we just substitute it in the value. At a particular instant, a source of sound of frequency 1000 hertz is at 2,1 and an observer at 5,5. The velocity of the source and observer were given. The velocity of the sound in air is given. Then they were asking what is the apparent frequency. See, you can solve it like what they have done, or if you are not a math person, probably you can try to draw the figure. You will be seeing observer will be somewhere here, source will be somewhere here, observer will be somewhere here, and this velocity is something like this velocity is something like this. Then you need to resolve all the velocities along the line joining. So, line joining vector you can calculate, which is going to be this white line is going to be, yeah, you can see 5, 5 and 2, 1. So, it is going to be 3 I cap and 4 j cap. So, this projection along this direction, that is going to be velocity of source along the line joining. Similarly, this projection along the line is going to give us velocity of the observer along the line joining. Then you can use Doppler's effect, then you will be getting the apparent frequency. Now, those who are using tan 53 is 4 by 3, tan 37 is 3 by 4, you may get slightly off answer, maybe like you could have given for correction for range. They were not exactly this much 53 and 37, but we will be roughly using them, right. Thank you.